Now we're going to switch modes and go through a few case studies. We'll start with an example of a multi-unit residential building in Kelowna, and then we'll make that into a mixed-use building by adding a daycare. Finally, we'll look at an office high-rise with the district energy system connection. I'll be showing both the case studies and how to complete the checklist on the screen, but you can have the option to follow along. We just suggest that you download a blank checklist from energystepcode.ca before going any further. So on the screen, we have on the left a Word document that summarizes the case studies that we'll be going through, and on the right, a blank copy of the checklist. So our first case study is a multi-unit residential building, or MURB, in Kelowna. And this all-electric building is currently in the design phase, submitting for BP. It has a high-performance envelope, efficient energy recovery ventilators, and split heat pumps in suites and amenity spaces that are sized for full cooling. Corridors are pressurized with central rooftop ERVs, and domestic hot water is provided with in-suite electric resistance tanks. Now, these tables provide us with some of the information that we'll need for the checklist, but you can see we haven't gone through and provided every entry just for time's sake. If we look at the checklist, we can see that the summary tab is of course blank because none of the information has been left yet or entered yet. But we can come and revisit this in a few minutes once we put some information in. So starting on the checklist tab, we can enter some of the basics for the building. We haven't been given an address, but we do know that the project stage is at building permit. We'll select that from the dropdown. For the date, I'm just going to put in today's date. And that will automatically populate the applicable version of BCBC. The building height is given to us as 5 stories. And we know that the jurisdiction is Kelowna. So in the drop-down menu, I can just type a K and it will take me down to that part of the list. And I'll choose Kelowna. I noted this in earlier recordings, but some of the jurisdictions don't have any information associated with it. So you'll need to just enter that yourself if that's one of the areas that you're working in. But when I choose Kelowna, the heating degree days and the associated climate zone is populated. Now my project is MURB only, which is a step code occupancy. So I can skip past section B because there's nothing I need to enter there. In section C, I'll start by selecting from the drop-down menu that the MURB is Group C or other residential occupancy classifications. The model floor area is 5,000 meters squared. The step required, which is shown over on the left, is step 3. And the GHG emissions level is EL2. Now that I've selected those, my TUI, TEDI, and GHGI requirements are populated for that space type. And because it's the only space type in the building, those same numbers are repeated down to the area weighted totals for section C and for section D. So now that we've outlined the requirements, I can go through and put in the energy use of my model to see if it complies. So this section includes or provides the energy results that we can use. And we've ordered them in order of the standard end uses just for ease. So if I paste my energy use there, you can see that we have an end use here that was not included in the standard checklist, which is elevator. So I'm going to put that in myself. And then I have to identify the fuel type for all of these. And since it's an all-electric building, I can just copy and paste that information down. Now that this is complete, I have my energy usage and the emissions factor gets pulled in for electricity. So I also have my total annual emissions for GHG calculation purposes. However, I still need to enter the annual thermal energy demand for Teddy, which is provided to me here, 190,000 kilowatt hours per year. And then that's translated to a kilowatt hours per meter squared based on the model floor area. And since my building is only step code occupancy, I can set this value equal to the whole building value for now. Now, because I have an entry in the cooling row here, this cell has become yellow, so I need to enter the annual cooling energy demand for steady, which is 30,000 kilowatt hours. Because I'm only using electricity, that emissions factor is pre-populated, so I don't need to enter anything into this section. And without any renewables, I can also skip past this section. Now for the overheating limits, the question is my project subject to overheating limits? Well, the case study has told us that we have full cooling, which means that no, we are not subject to overheating limits. And then as for the corridor pressurization adjustment, this information is provided here. The number of suites pressurized is 50 at 8 liters per second per door, and the associated corridor area is 500 meters squared. And we know that the makeup air-fuel type is also electricity because it's an all-electric building. For the suite submetering adjustments, we can mark that it's not applicable to this building because we don't have a hydronic system in the suite. And now that I've filled out this section, the adjusted whole building performance is being compared against the requirements. And we can see that, yes, my project complies across all 3 metrics. And also within the step code only, it also complies. If I were to go back to the summary page, I'd see, first of all, that the information about the project that I entered is in there as well. And the requirements and levels achieved are also being shown. And then we get to section F, where we enter a summary of building performance characteristics or modeled inputs. And once again, we're not going to fill in every cell. We just want to point to a few of them with you. So the first one is the weather file. So here, what we've done is actually identified the name of the file that gets used, and then we added in brackets 2016 to represent that it's a 2016 CWEC file. But you notice that's quite a long name, and so the year gets cut off. So it's just kind of another reminder to consider submitting the Excel file along with your submission in case anything like this might happen, because that would be unreadable in a PDF. Now for the document references, we might want to put the architectural drawing set name, issued for BP, the date issued, which we were given as 5th of October, and the ARC name, company name, and do the same thing for the mechanical and electrical drawing sets and any other relevant documentation for the energy model. For the air tightness, we're given that the assumed design air tightness test rate would be 0.89 liters per second per meter squared at 75 pascals. So that's the test rate that the team is basically aiming for when they finally get to the testing. And that corresponds to a modeled infiltration rate of 0.2 liters per second per meter squared of facade area at operating pressure. And then finally, we've been asked to complete the mechanical section based on the descriptions that we were given in the case study. So these are up here, energy efficient ERVs and split heat pumps. So I would probably choose as the heating system type air source heat pump is the plant, and we could even choose that again for the system type. And then as a description, I might just grab what's written in the case study there, which really provides the information that any reader would need. So after that, we would just go through and complete the same information for cooling, domestic hot water, and then finally enter our own contact information and the date that we're submitting the checklist. Moving on to case study number 2. What we did was we took this same MURB and we added in a daycare on the lower floor. So we're really calling it case study 1B. So what this means is we're now going to have information to enter into section B because the daycare has a reference energy model. Now, the daycare is noted as group A2 major occupancy classification. And we're told that there's 1,000 meters squared of model floor area. The requirement for the daycare is that it meets step 2 NECB. Now, for this daycare portion, I need to identify what is the total annual thermal energy demand for that reference building. And that's given here as 60,000 kilowatt hours. That now populates the TEDI. The annual energy end use for the building, not by end use, by fuel type, pardon me, is given here. And at the moment, we are just using electricity, 150,000 kilowatt hours. So with that populated, what we can see is that my baseline daycare uses 150 kilowatt hours per meter per squared of TUI, 1.7 GHGI. And so these amounts blended with the MURB requirements now form the new limits for the whole building performance. The other thing to note is that in the residential areas, we've had a few changes. The heat pumps were replaced by electric baseboard heaters, and corridor ventilation is now provided by natural gas. We're also at occupancy, and the post-construction air tightness testing has been completed. So we're going to go through and make those changes now. So first of all, with an extra floor, a higher floor area, we now have increased energy use. So I'm going to paste in the new values now that the daycare has been added. And we have a new row here. This is the natural gas heating that corresponds to the makeup area unit, which is now on natural gas instead of electricity. So you can see this line is for electric heating, this is for gas heating. The other change we need to make is that now our annual thermal energy demand for TEDI for the whole building has increased to 220,000. And the step code portion is no longer equal to the whole building. We're going to have to set that on its own. The annual cooling demand energy for SETI is given to us as 12,000. And once again, this example doesn't have any emissions factors other than natural gas and electricity or renewable energy, so we can keep scrolling past those sections. Now, without full cooling, this project is subject to overheating limits, so we have to change that to a yes. The overheating limit is given to us here as 200 hours, and our worst zone is experiencing 150 hours. So that meets the requirements. The other change that we have to make is to our corridor pressurization adjustment because it's now using natural gas instead of electricity. Now that we've made these changes, we can look at the results and we see that yes, the building does still comply against all requirements. The last item we were provided with was the air tightness test result. Oh, I forgot to change the project stage. Now that we're past building permit into occupancy, I need to select that in section A. And what that will do is activate the actual test result for the building. So we've been provided with an air tightness Result of 1.5 liters per second per meter squared at 75 pascals, which is equivalent to an infiltration rate of 0.31. I would also need to change out the mechanical system type because it's not a heat pump anymore. I guess I could also put here no central plant. That would be completely fine as well. And I could put this as an electric baseboard as well. I'm apparently hitting the wrong button. And here we go. And that's case study 1B. Next, we'll be completing the checklist for a case study for an office high-rise with district energy system connection. Building 2 is a high-performance high-rise office building in Richmond. It will connect to a district energy system for space heating requirements and is voluntarily targeting Step 3 energy performance above the city's Step 2 requirements. There are no GHGI requirements. So again, we're going to be only populating portions of the checklist. So we'll start by putting in today's date. Without typos, which will populate the version of the step code and the BCBC. We've been told that the project is 12 stories tall and the jurisdiction is Richmond. That auto-populates my heating degree days and climate zone. Now, I don't have to enter any information into the baseline section, so I'm going to scroll through to section C. And I will begin by selecting the occupancy classification for office, which is group D. The case study tells me that the model floor area is 9,000 meters squared, and that the step required is step 3. There is no EL requirement at this time. Once again, now that I've filled that information out, the limits for this building are populated in the remaining sections. Now to enter the model building performance results. As we did last time, I can copy in my end uses and paste them into the appropriate column. Now we've got 2 end uses that are unique to this project and there aren't the standardized ones. So we have elevator and heating electricity. Now I can go and populate the fuel type for that as electricity. And in fact, I think everything else is going to be electricity. The one fuel type that will be different will be the other heating end use, which we've been told from the case study is the district energy system, or DES. Now I haven't entered any information about this DES yet, so I have to go do that. So down here in the emission factors and renewable energy section, I have to provide a name for my DES, so I'm going to make one up. And now I have to provide an emissions factor. This has been given to me here as 0.05 kilograms of equivalent CO2 per kilowatt hour. And my source for this information is the case study, but of course you would need to provide something to the satisfaction of the jurisdiction. Just finishing out the modeled outputs for the entire building, I need to enter the annual thermal energy demand for Teddy, which is provided here, for SETI. And then because I only have a step code portion of this building, I can set the annual thermal energy demand equal to the whole building. Because this is an office, this project is not subject to overheating limits. and there's no suite submetering requirements. You could potentially also just leave those blank because it's not required, but if for completeness, you might want to fill those out. And we can see that once again, our project is complying with the requirements at a whole building level and at a step code level. Although only just with the TUI, we're very close. So if this were my project, I would probably suggest that we try to build in a little bit of a bigger buffer with the design team. Now, for this case study, we did identify a few of the key inputs that can be entered into here. We're not going to go through them on the recordings just for the sake of time, but anyone who's new to the checklist is, of course, welcome to just take a look at them and get used to sort of the type of numbers and values that you might be entering into the checklist. But this wraps up the case studies portion of the video.